evening. I'm here to have fun with sensXPERT here in Schwanthaler Straße in Munich. As you know, guys, I've been with Composites Lounge, Composites 360 on tour, my vlogging style. I've been at Hannover Messe this week. I've been at Tech Textile. Then I had birthday. I'm 53 years old. And today, on the Saturday, I have an expert here, and I would like to interview him on what's going on with testing materials, particularly in plastics and composites. So, and if you are watching now from the United States, my expert here is Dr. Phil. But it's not Dr. Phil you know from TV, yeah, who is the psychologist. This is Dr. Phil Gralla. And with Dr. Phil Gralla, we will dive now deep into analysis systems, inspection systems. I'm here in the laboratory. We have not a polished environment here. This is a laboratory. And in the laboratory, as you know, you have a lot of devices, a lot of cables, a lot of electronics here. You have shelves where parts are into it. And I love it because this is engineering, and engineering is the heart of our material science. So let's deep dive with Dr. Phil Gralla. And now we are turning back to our inspection of materials here, and I'm really keen to see what the result is.
So the first one is our dielectric sensors, because we are measuring in process. And this one is an example where we, well, actually it's not just an example, this is a real sensor. You can see here, this is the sensor we are using. And for the lower frequencies, so especially used for thermosets, this one will be integrated into the mold. So it needs contact to the material. That's a requirement we have. And for injection molding, we would place this one directly in the mold as part of the mold. You can put it in later after you already finished the mold, but it needs to be physically altered. To demonstrate how it works and what we can see, we actually go to this one. This is a laboratory press. So this is not a real mold, it's too small, but we use this one for testing and analyzing. And we have, as we see before, right, we have our plate here, we have the sensor. Now we have this ring we put on top of it, need to close it a little. And into this kind of mold, actually this, we can just put our material. So I will have some epoxy, I mix it, put it inside, then we do our isolation, we close, and then we start our program. It will go down, heat a little, apply some pressure, and we can see what actually happens with the material. And this is a very interesting part, because if you look, we have also a DSC, typical laboratory equipment, for testing material. And this is kind of a golden standard. A lot of people use it for analyzing material beforehand. The problem is you always need to take out part of your product, of your final composite, grind it very small, and then you can analyze inside. So you cannot do it in process, only after or before. And here we can actually see in the process. We have two tools. One is for controlling the press. So this is the first one I will actually start. Where we have here always our press. Not going to do it right now, later. I will start it. It will heat and go down. And since we switched to our new sensor, we actually don't see anything here. There's nothing connected. This is only for controlling. And for checking what happens, we use this tool. It's a developing tool that we have for our newest kind of sensor. So this is something where I'm quite involved in gathering the data, displaying the data to make sense of what is coming out. And so this is a little tool we wrote in SDL, pure SDL and C++. We didn't use anything that was already done, and the reason is that we get a lot of data, especially when starting. So we have an analyzer board which can already decimate the data, which is good because otherwise we have to stream gigabyte per cycle. And when we have this one, most of our graphics tool were not able to keep up. So we had to make some small adjustment. That's why we have this tool to actually be fast enough gathering the data and displaying it with some ring buffers and yeah, mathematical tricks to make it fast enough to process all the data coming in and analyzing it. We have Fourier transformations actually on FPGAs directly to get rid of the noise, to extract the most important data, and all this one is then being transferred in a CAN interface. Why CAN? Well, our devices are also made to go for sewer rehabilitation. In sewer rehabilitation we have cable lengths of around 300 meters and temperature around 120 to 140. So we cannot work with a regular network cable. We can also not use any like Wi-Fi controlled elements. That's why we actually use this CAN technology, which for some people that are into cars might know that's also how your components in the car communicate with each other. Alright, so I mixed some epoxy here. No, actually resin, and we can fill something in. Okay, so we fill some of our material inside here, and we want to see the curing. So what is actually happening, why it cures. So we'll close this one for a moment, and we can focus on this machine. Then I will close this one. We can stay focused here. I will start the press. Okay, the room has to heat up a little. It says it's not inside, and now we can start. We already started our press, seating up, pressing the material down. To see actually what happens with the material, right now we don't see anything. And that would be quite normal in your process as well. So what we can measure is, of course, some temperature, if we have temperature sensors, also from the machine, and the pressure itself. But this does not tell us directly what happens with the material. We can use the sensors that I showed you at the beginning and to see the viscosity of the material. Actually the ion viscosity, we have a dielectric field applied with a frequency, and we check how our material, the ions, are ionized and how they align, like how do they respond to the frequency. And this tells us how the material is curing. And the data is gathered live, so you actually have the possibility, this process also is 15 minutes. Alright, so I showed an example about our press here, the laboratory press. So this is a very small device if compared to injection molding. And for the next step, we actually want to have a look at the machines that we are using, our IPCs. So the idea from sensXPERT was, and still is, to bring technology and analysis from the lab to our real production and use it in production. So we cannot just use the press that you have seen, but instead we have to integrate our technology into already existing processes. And to do that we have our sensors, but the second part that is important is our edge device, or we call it the edge device. The edge device consists of two parts. One is actually an analyzer, so it takes the analog signals and signals from the different sensors to transform them to something we can use. And the second part is an IPC. An IPC is a computer basically without any screen, which does all the processing. Now you might wonder, if we say we want to do something in process and we can show what happens, how does that work if there is no screen? And the trick is you can access this IPC on a local network. It has two network connections, one for local, one for online, if you want to upload data to the cloud, which I do recommend because then we can actually work with historical data. And you can access this and then basically like a web page open it, and there you have all the information live. We will show that later so that you have an idea what happens. And for everyone who can actually see it, the lab here is small, like it's for 4 or 5 people, it's one room, so there is no mold machine next to me. But what we have instead is a mini hill and an NI hill. What are these? Well, they are, hill stands for hardware in the loop, and this hardware in the loop we use to simulate the real machine, but by actually sending signals. That's why it's called hardware in the loop. So this one sends us trigger signals, sends us analog signals that simulate being a real machine. So our IPC and our analyzer has no idea that he is somewhere else. And this one is done for testing. So we can in here test different scenarios. We can also check if there is something happening at the customer that we replicate. What is it doing? And for some of you who might have been at a fair and seen measurements and have wondered where this one is coming from, if it's live measurement, it's probably coming from one of our hills. This little blue box here is our so-called IPC, which actually is 2 parts. On one side is an analyzer, on the other side we have our IPC. And they come as a box combined, makes it easier for install. And our sensors are being connected to this channel 1 and 2. So you can have 2 sensors to the same IPC. Either if you would like to have 2 measurements at the same part, or you might have other purposes, or you can also only use one of them. Then you see here, I talked about it before, 2 LANs. Why 2? One for local access, if you do not want to have it in your regular network, and the other one we use to have connection to our cloud. We do use the cloud to upload data, to retrain our models, to monitor models, and also to give the option for every customer to get an overview about different installations, or one installation over the time. How is it performing? How is it performing in comparison? You can also detect if things are out of order. So that is the purpose of cloud in comparison to what is happening on this IPC. And for our IPC, that is already all. It's the box. You connect it, and to see what happens inside, you will need to take a different computer. Maybe you have one in your network or a laptop, and then you can work on this one to see what happens. What I will do to show you what actually happens inside this box doing a measurement, we have connected this one to one of our hills. So it is simulating a production by sending signals. So the box doesn't know it's not in a real production. For it is in a production, gets analog signals. So it is really a hardware made simulation. And it is gathering this information, and we can see live what happens. What can you see and what can you use?
I have a question to you. The box here, there's a lot of technology inside it, but who would be responsible for this box at your customer? Is that the IT department? Is that a production engineer? Describe me who at your customer will be operating or setting this up and operating this.
We have to distinguish between installation and operation. Prior to the installation, we have a couple of requirements that must be met.